Our next topic is the convergent sequence. When we say a sequence is convergent, when the value of the terms of this sequence converge to a definite finite limit point when the terms increases. Okay, see that then we call the sequence is convergent and to that limit point. If we take a sequence here like that, 1 plus half, 1 plus 1 by 2 to the power square. The third term is 1 plus 1 by 2 to the power cube. And nth term is 1 plus 1 by 2 to the power n in this way. Okay. If we represent the term graphically, here along the x-axis we represent the term here 1, 2, 3, 4, 5 like that. Okay, and this is the line, this is 1. Okay, so here the graph will be like you see that the terms increases and the graph continuously become more closer to the line y is equal to 1. Okay, so it becomes more closer to 1. So 1 is the limit point of this sequence. 1 is limit point of the sequence. Okay, so this sequence is convergent. It converges to the definite limit 1. Okay, remember we represent the convergent sequence as limit n tends to infinity un is equal to L. That means the terms increases to infinity. So here it is n tends to infinity. We call it n tends to infinity. And un is the nth term. It converges to the definite limit. So n is the limit. So for the convergent sequence, there must be a definite limit. Okay. So another thing you remember, limit n tends to infinity 1 by n always 0. Okay. N is where n belongs to set of natural number. Okay. Another things you have to remember to proceed further is if we take a number r whose numerical value is less than 1, then you must remember limit n tends to infinity 1 by r to the power n is always 0. Okay, and if the numerical value of r is greater than 1, then limit n tends to infinity r to the power n, that is infinity. It means the series doesn't converge. That means the series is divergent. Okay, it doesn't have the definite limit, so it is not convergent. That means it is divergent. Okay, now we will discuss how to find out the limiting value of a sequence when the nth term is given. Okay, so here you see the one sequence whose nth term is 5 by n is given. Okay, so when n tends to infinity, what will be the limit value of this sequence? So here we know that we have already know that limit n tends to infinity 1 by n is always 0. Okay, so here for this problem, to understand limit n tends to infinity 5 by n, that means if n tends to infinity 1 by n is 0, so this is also 0. Okay, now our next problem is given. The sequence with nth term is given here. We have to find out the limiting value. So here you see that if we directly put n tends in infinity, that term become infinity by infinity, because on the numerator this become also infinity, and in the numerator, or sorry, denominator also it become infinity. So this is indeterminate form. Okay, so for this type of problem, what we will do? So here you see that we will divide by n on the numerator and denominator both. Okay, so here limit n tends to infinity. If we divide by n, then n plus 3 by n, and in the denominator n minus 2 by n. Okay, so here it becomes limit n tends to infinity, it becomes n by n plus 3 by n, here n by n minus 2 by n. Okay, so here now limit n tends to infinity, each and every step you have to write it. Okay, so here n by n is 1, so 1 plus 3 by n, and in the denominator this become 1 minus 2 by n. So here if we consider that limit n tends to infinity 3 by n is 0, and limit n tends to infinity 2 by n is 0. Okay, so it becomes 1 plus 0, 1 minus 0. So here the limit value is 1. Okay, so the next problem is, the nth term is given 2n by n square plus 1. So how could we solve this? Here also limit n tends to infinity, we divide by the highest power of n. Okay, so here highest power of n is n square, so we divide numerator and denominator by n square. So here 2n by n square, and here n square plus 1 by n square. So here it becomes limit n tends to infinity, on the upper numerator what we have 2 by n, and here we have n square by n square plus 1 by n square. Okay, so here limit n tends to infinity, here we get 2 by n, here this part become 1 plus this part become 1 by n square. Now we know that limit n tends to infinity 2 by n is 0, and 1 by n square is also 0. So it becomes 0, 1 plus 0. So this becomes 0. So the limit value is here 0. To find or write down first 5 terms of the following sequence. So here we see that the explicit form is given the nth term. From here we have to, first problem is that we have to find the first 5 terms of this sequence, and we have to determine whether this sequence is convergent or not. Okay, so for first problem what we will do, we will put n is equal to 1, 2, 3, 4, 5. Okay, n is, we know n belongs to set of natural number, and n is greater than equal to 1. So first u1. So when n is equal to 1, what will be here? There is also 1. So that is 3, 1, 3. u2, 3 square, 9. u3, 3 cube, 27. u4, 3, 4. That means 81. And u5, 3 to the power 5. That means 243. So first 5 terms we have to find out. The first 5 terms is this, for this sequence. Okay, now we have to consider whether it is convergent or not. To find the convergence, what we will do, we will take limit n tends to infinity un. So here limit n tends to infinity 3 to the power n. So what we have know that if the numerical value is greater than 1, then limit n tends to infinity r to the power n is infinity. What does it mean? This is not convergent. This is divergent sequence. So here it is infinity. So the sequence is divergent. Okay. Here you see. Here also we have to find the first 5 terms for this sequence. So in a similar manner, we will take n is equal to from 1 to 5. So u1 is here 1 by 1 plus 1. In place of n, we are putting 1. So that is half. u2, it is 2 by 2 plus 1. That means 2 by 3. u3, 3 by 3 plus 1. That is 3 by 4. u4, that is 4 by 4 plus 1. That means 4 by 5. u5, that is 5 by 5 plus 1. That means 5 by 6. That's all. Now the next problem, whether it is convergent or not. So un, so to check this, what we will take? N tends to infinity. So limit n tends to infinity n by n plus 1. We can see this is also indeterminate form, because if we put infinity in the numerator and denominator, both will become infinity, that is indeterminate. So for this type of problem, what we will do? We will divide numerator and denominator by n. So the highest power with the highest power of n, but here n is the maximum power of n is 1, so we divide by n only. So here limit n tends to infinity n by n plus 1 by n. So here limit n tends to infinity n by n is 1, and here also n by n plus 1 by n. So here limit n tends to infinity 1 by 1 plus 1 by n. So what we know about 1 by n? That is limit n tends to infinity 1 by n is 0. So our answer is 1 by 1 plus 0. So the limit value is 1. Next type of problem is given with the sequence is given, and we have to determine whether it is convergent or not. To do this, we have to find out the nth term first. So here you see that the sequence this is here 3, here 5, here 7, here 9. So to find out the nth term, can you imagine what can be there in place? Here is 3, here is 5, here is 7, here is 9. So here would be, it is of the form 2n plus 1. You should have to think it. Okay. Look at this. If we put 2n plus 1, and in place of this is the term n. So when we put n is equal to 1, that becomes, so when we put n is equal to 1, it becomes 2 plus 1, that is 3. When it become, we put n is equal to 2, that is become 4 plus 1, that is 5. n is equal to 3, that becomes 3, 6 plus 1, 7. n is equal to 4, that becomes 8 plus 1, 9. So in this way we have got all these. Okay, so it satisfies all this part. Okay, for 12 plus 1. Now we have to consider this one. In this term, how it is, in which form it is. Okay. So here 1 by 2, 1 by 3, 1 by 4. So we can see, you can easily tell is when this is the term 1, this is 2. When the term 2, this is 3. When the term 3, this is 4. So it is increased by 1 from the number of terms. So here we can write n plus 1. So when n is equal to 1, first term, this is 2. When n is equal to 2, second term, this is 3. N is equal to 3, this is 4. So this satisfies this part. Okay. So here we can say that for this sequence, the nth term, the general term is of this form. Okay. Now we would consider whether this is convergent or not. So what should I do? We will take the n tends to infinity, limit n tends to infinity. So here 2n plus 1 plus 1 by n plus 1. So here we can easily separate two parts. Limit n tends to infinity 2n plus 1 plus limit n tends to infinity 1 by n plus 1. Here you see that n belongs to set of natural number and this is greater than equal to 1. So it becomes, its numerical value is become more than 2. So if we take n tends to infinity, it becomes infinity. Okay. And as it is in the denominator part, we know 1 by n is 0. Here in place of there is 1 by n plus 1. So it is also 0. So the result is infinity. The sequence, so what we will tell from here, the sequence is divergent. So sequence is divergent. Okay. Now look at this problem. This problem also we have to find out the sequence is convergent or not. Here in the similar manner we will find out the nth term. Okay. So to do this, you first look at this sequence very carefully. You see that this term is 1 for each. This part is 1 for each term. Okay. For each term, this is 1. So for the nth term, un, there must be 1. Now we consider here is half, here is for the second term, this is 1/3. For the third term, this is 1/4. For the fourth term, this is 1/5. So it increases just 1 for the number of terms. So here we can write is 1 by, that must be 1 by of the form 1 by, and here for first term this is 2, second term this is 3. So here just it is increased by 1 from the number of terms. So for nth term that will be n plus 1. I hope you understand this. Okay. So we have got only the numerator part. For the denominator part, again we see here the first part of all the term is 2. So here we write 2, there will be 2 obviously. And the second part, here is 1/3, 1/4, 1/5, 1/6. So for the first one it is 1 by 3. For the second one it is 1 by 4. For the third one it is 1 by 5. So then it is increased by 2 from the number of terms. So for 1 it is 3, for 2 it is 4. Okay. So here for n it is 1 by, there must be 1 by n plus 2. Okay. N plus 2. Number of terms is n. From here it increased by 2. From here this is 1 plus 2. This is 2 plus 2. This is 3 plus 2. Okay. So we have got our nth term. Now we will consider whether it is convergent or not. So to do this, we take limit n tends to infinity 1 plus 1 by n plus 1. Here 2 by plus 1 by n plus 2. Here you consider that we know that 1 by n form is tends to 0 when n tends to infinity. In place of n, there is n plus 1. In case when we increase our term n tends to infinity, it will similar to 1 by n. Okay. So 1 by n plus 1 is also 0. Similarly, 1 by n plus 2 also 0. If 1 by n is 0, 1 by n plus 1 also 0, 1 by n plus 2 also 0. Okay. So this term is 0. This part is 0. Okay. So what we are left here? So from here 1 plus 0, that is 2 plus 0. So our limit value is half. So what we will call from here? That sequence is convergent. Sequence is convergent. Okay. And we will discuss another type of problem. Here given that write down first 6 terms of each of the following recursive formula. Okay. So from there is formula is given and the first term is given. From here we have to find out first 6 terms. So here u1 is 3. Now what we will find? u2. Okay. So here if we put in this formula here, so here we write there, look at this, u n plus 1. So if we put n is equal to 1, then we are taking n is equal to 1. Okay. We are taking n is equal to 1. So here 1 plus 1 plus 3 u1. 1 plus 1, 3 u1 is 8. Okay. So from here we get u2 plus 3u1 is equal to 8. Among these we know the value of u1. What is this? 3. So u2 plus 3 into 3 is equal to 8. So here u2 is equal to 8 minus 9, that is minus 1. So we have got u2 is minus 1. Okay. Now we take n is equal to 2. So here from we can write u2 plus 1. Here n is equal to 2. So in u2 plus 1 plus 3 u2. Okay. So here u2 plus 1 means u3 plus 3 u2. What we have find? u2 is minus 1, 8. In place of u2 we are taking minus 1. So minus 1. So u3 that is minus 3 plus 8. So here u3 is 8 plus 3. Minus is going to that side. So here u3 is 11. Okay. So here u3 is 11. Okay. Now we are taking n is equal to 3. So when n is equal to 3, here 3 plus 1 and here 3. So here u4 plus 3, u3 means 11 is equal to 8. So here u4 plus 33, 8. So here u4 is 8 minus 33. Okay. So here u4 is minus 25. Okay. So here we get U4 is minus 25. So 1, 2, 3, 4. We have to find out more 2 as there is 6 term. So here now we are taking 4. So here 4 plus 1, 4. So this is U5 plus 3 U4 means minus 25 is equal to 8. So here U5 minus 75 plus 8. So here U5 is 8 plus 75, that means 83. Okay. Next is, so U5 is 83. So next is, you take U, n is equal to 5. So here 5 plus 1, 5. That is U6 plus U5 is 3 into 83, 8. So U6, that is 8. So U6, that is 8 minus 2, 49. So that is U6 is minus 241. So U6 is minus 241. So that are the 6 terms of this sequence. Okay. The next problem of similar category is un plus 1 is equal to un is given. Okay. So the first term is here u1 is equal to 5. For the second term we take n is equal to 1. N is equal to 1. So that is n 1 plus 1 2 u2, that is 1 by u1. Okay. So here we put the value of u1, that is 5. So that is 1 by 5. Okay. For the next one, n is equal to 2. So here if we put n is equal to 2, this is n 3. Okay. N is equal to 2, this is n 3. And 1 by n is equal to 2 means 1 by u2. Okay. So here u2 you have find out u2 is 1 by 5. So 1 by 5. Hope you understand. u2 is 1 by 5. In place of u2 you are putting 1 by 5. So that becomes 5. Okay. So what you have got, u1 given 5, u2 you have find that 1 by 5, u3 is again 5. Now for n is equal to 3. So here putting n is equal to 3, that become u4 is equal to 1 by 3 u3. So here in place of u3 again you are putting 1 by 5. So here u4 is 1 by 5. So now we are taking n is equal to 4. So if you take n is equal to 4, that become u5, here u4, 1 by u4 means 1 by 1 by 5. So it become again 5. Okay. The next one, n is equal to 5. N is equal to 5 means u6 and here u5. So here 1 by u5. U5 you have got 5. So here 1 by 5. So u6 is again 1 by 5. So the term is like 5, 1 by 5, 5, 1 by 5, 5, 1 by 5. Okay.